Oh yeah. So does anyone need me to do any question? Right, I'll just go with 1, 2, yeah, Eva. 5 part 2, right, okay. So 5 part 2 is, it's find the turning point and determine the nature of each turning point, okay. So it's y equals x squared all over x plus 2. So at the turning points dy dx is equal to 0, right, okay. So that's the golden rule, right, okay. So we need to differentiate. So to differentiate here, girls, we need the quotient rule. So you need u is equal to what's above the line, v is equal to what's below the line. So du dx is equal to 2x, differentiating there, and dv dx is equal to the number in front of x, which is 1. Okay, I won't bother writing out the rule, but it's v times du dx minus u times dv dx all over v to be squared. V to be squared was x plus 2b squared, right, okay. Will I simplify it? Yeah, I will. So I'll go 2x squared plus 4x minus x squared all over x plus 2 to be squared, and that is x squared plus 4x all over x plus 2 to be squared equals 0. Right, okay, so I'll let it equal to 0 because dy dx equals 0. Is that okay? Then I move it up. Have I cut you off? Am I okay to go? Right, okay. Stick that over 1. You can't stick it over 0 because 0 is over 0. So 0 over 1 is just 0. So cross multiply, you get x squared plus 4x equals 0, but that is 0. Okay? So remember, you put everything over 1. So 0 over 1 is 0. 0 over 0 doesn't exist. So you have to put it over 1. So to solve here, take out what's common, x plus 4 equals 0. So you let the x on its own equal to 0, and you let x plus 4 equals 0. So that means x equals minus 4. Right? Of the turning point. Yeah, turning points. Yeah. Okay. Yeah, I'm okay. So for each x, I have to get a matching y. So right back up to the start, right to the curve, right, x squared all over x plus 2. So when x is 0, y, that will turn out to be 0 over 2, which is 0. So there's 1.00, right, okay. And the other point, everywhere I see an x, put in a minus 4. So it's minus 4 to be squared all over minus 4 plus 2, which is 16 divided by minus 2, which is minus 8. So that's minus 4 minus 8. Okay. Will we bother with d2y dx2? Or we won't. We'll just say, look, that's minus 4 minus 8. Which one's up high? Which one's down low? Which one's a max? Which one's a min? That one's 0. If you were to draw it, 0, 0 would be here. And the other one, minus 4 minus 8, would be down here, wouldn't it? So this is a max and this is a min. You're very quiet, so that's suggesting to me I've made a mistake somewhere, have I? No? Right? We're all okay? Right? Okay. You could go down the d2y dx2 route, but we don't need to. Right? Okay? You don't need to do that unless they specifically tell you to do it. Okay? Is that alright? So that was number 5, part 2. Does anyone need any other bit of the homework done? 6, yeah. Okay, so number 6. find the maximum and minimum of this f of x equals 4x plus 4 over x. So the easiest way to differentiate here is to bring up that x. It's on its own. Like if that was 4 all over x plus 2, something like that, you'd have no choice but to do the quotient rule. But because it's just x on its own, you can bring it up. So I'm going to write that before I start. I'm going to go, that's 4x plus 4x to the power minus 1. Because that's x to the power plus 1 underneath the line. When you bring it up, it's minus 1. Right? It's the easiest way to differentiate it. So then differentiate, I'll call it f dash of x or dy dx, whatever you like. 4, right, sorry, and bring the power down in front. That becomes a minus 4. X, reduce the power by that, and you get minus 4 to the minus 2. Right? Rewrite that as 4 minus 4 all over x squared. So you let that equal to 0. Okay? So get a common denominator. Common denominator is x squared. That's over 1. 1 into x squared goes x squared times, so that's 4x squared on top. X squared into that goes 1s, 4 1s are 4, and that's just 0. Is that right? I've evened up both sides, so I can drop that. So it's 4x squared minus 4, that's x squared minus 1 when I divide across by 4. Right, okay, that's the difference of two squares. So that's x and x, 1 and 1, and a plus and a minus. So then you let each bracket equal to 0. So x plus 1 equals 0 means you get x is equal to minus 1. X minus 1 equals 0, you get x is equal to plus 1. Then for each y, I need a matching x, right? Okay, so that means y is equal to 4 times 1 plus, 4 times minus 1 plus 4 all over minus 1. That be minus 4 is be minus 8. So that's minus 1 minus 8. And then for the other one, y would be equal to 4 times 1 plus 4 over 1, which would turn out to be y is equal to plus 8. So that's 1 8. So then you know, if you draw that, minus 1 minus 8 is way down and 1 8 is up. So that would be the min, and that would be that. Yeah, sorry. Is that okay? Are we okay? Right, any other questions from last night? 8, yeah. Are we good? Going, gone? Yeah. Okay, so number 8, right, again, the function is y equals x minus the square root of x, right? So we want to differentiate, and we're finding the turning point. It's only going to be one answer, right? Okay, so I'm going to write that as x minus x to the power of a half. That's the square root is. Then I can differentiate. So you get dy dx, differentiate x on its own, you'll get 1. Right, differentiate that, bring the power down in front and reduce the power by 1, so it's minus a half. Okay, is that alright? So I'm just going to fix that. That's 1 all over 2 times the square root of x. As in when I bring it back downstairs, it's x to the power of a half, and that's the square root of x. Is that alright? Equals 0, right? Because at the turning points, dy dx equals 0. Going to get a common denominator is 2 root x. So that's 1 into that goes 2 root x times by that, minus 2 root x into that goes 1, so 1 times 1 is 1 equals 0. I can drop the common denominator, so I'll get 2 root x minus 1 equals 0. So that means 2 root x equals 1. So that means the square root of x equals a half. And then if you square both sides, you'll end up with x is equal to a quarter. then get the matching y. So y is equal to x minus the square root of x. So that's a quarter minus the square root of a quarter. Square root of a quarter is a half. That's a quarter minus a half, which is minus a quarter. So your turning point is a quarter minus a quarter. Now we've only 1 point. I have no idea what that curve looks like. I haven't a clue. Right, okay, so I have to use the d2y dx2. Do you all see that? Because I have no clue what that looks like. Right, okay. So you know, if I knew in my head what it looked like, I could say, oh, it's a min, it's a max, whatever it is. I haven't a clue what that graph looks like. Okay, so I need to use the d2y dx2. So if it's greater, I have to get d2y dx2, I have to fill in the x, right? And if it's greater than 0, it's a min, and if it's less than 0, it's a max, right? How do I know that? I have to learn it, right? Okay, so I have to get d2y dx2. Right, so where was dy dx? Dy dx is here. 1 minus a half x to the power of minus a half. So I'm differentiating this. So when I differentiate 1, I get 0. Bring the minus a half down, so it becomes a plus, and a half by half is a quarter. X to the power of minus 3 over 2. Okay, we have calculators for this. Okay, so that's, where is it? When x is a quarter, that's a quarter multiplied by a quarter to the power of minus 3 over 2. So that would be 2. Yeah. Okay. So that's greater than 0. So that means it's the minimum turning point. Okay. Do you all see that? So this is where we had to use the rule, because a lot of the time you can visualize the graph, but we can't visualize that graph. That could look like anything. We don't know. Right? Okay. So you need that. A case of where you need the rule, okay, but we know it, so it's fine. Right, are we good? That was 8. Any other questions? Did I say leave out 9, but I mentioned to leave out 10 as well, because it's a point of inflection. That was fine. And 11 and 12, yeah, will be okay. Right, so I need to do point of inflection, so I'm not finished this section. It's just a point of inflection. Right, so this is me explaining what a point of inflection is. Please don't write for a minute. I'll give you notes in a minute, okay? I want to explain what a point of inflection is, right? Okay, so if you have a cubic equation like that, okay? Right, so the tangents are all on the one side of the curve, aren't they? Right, okay? And then there's a turning point, and then the tangents, right, are right all on the right hand side. They get to a point, right, okay, and the tangent will actually go through, and then the tangent will all be on the left hand side. Okay, so basically what we say is the curve, it was concave upwards, right, okay, that's concave downwards, and then it becomes concave upwards. You see that? Okay, that point there, that point right there is called a point of inflection. And what happens at the point of inflection is the curve changes from concave upwards to concave downwards, or whatever the hell, or vice versa, right? Okay, and the tangents, they're all on one side. At the point of inflection, the tangent actually goes through, and then the tangents are all on the other side. So the tangents are all on this side, down as far as that point, and then after that point, the tangents are all on the other side, okay? You don't need to know much about a point of inflection, only how to get it, right? Okay, so here we go. I wrote this out on Friday. That's why, and I kept it. That's because we didn't get this far. Okay. So the point inflection of a curve is the point where the curve changes, from being concave upwards to concave downwards, or vice versa, as in it could be the other way as well, as in it could be something like that, okay? So the point of inflection would be here. Okay, and at that point the tangents change from all being on one side of the curve to being on the other side of the curve. Okay, so it's a point of inflection, right? And as I say, we don't need to know a whole pile about it, only how to get it. Sorry. Are we good to go? We all okay? Yeah. Okay, so here's the rule. Cut to the chase. This is what I need to remember. At the point of inflection, d2y dx2 equals 0. So at a turning point, dy dx was 0. At the point of inflection, d2y dx2 equals 0. Okay, so what we do is, it's a point of inflection, so you know d2y dx2 equals 0. Okay, so I have to get dy dx first. So dy dx, differentiate there, and you'll get 3x squared minus 12x plus 9. Okay, but I need d2y dx2 because I'm looking for the points of inflection. So differentiate again, and I'll get 6x minus 12. And at the point of inflection, I know that 6x minus 12 equals 0. So at point of I, inflection, right, d2y dx2 is equal to 0. So you got d2y dx2, you let it equal to 0 and you solve. So we get 6x is equal to 12, so that means x is equal to 2. Now I need a point of inflection, so I need a matching y. So I go right back up to the curve, so it's x cubed minus 6x squared plus 9x plus 2, and fill in x is 2 there, so that's 2 to be cubed, that's 8, minus 6 fours minus 12, plus 18 is plus 6 plus, I think that's 8. Okay, so your point of inflection is 2, 8, and that's it. Okay, that's it, the end. Is that right? Yes. Yeah. Right, what I should have said, now you needn't write the next bit, right, okay, but what I should have said there a minute ago is there is no point of inflection for that, okay, there's no point of inflection, sure there isn't, because at no point does it change from being roundy upwards to roundy downwards, it's roundy upwards the whole time, right, they're not proper words, but you know what I mean, don't you? Right, okay, so like for a quadratic graph has no point of inflection because it doesn't change. Right, it's only for cubic graphs and upwards, right, that there'll be points of inflection, as in cubic graphs, x to the power 4 graphs, x to the power 5, etc. Right, okay, I'm not going to get any more done today now. I was going to do the next section, but you know, I think I might leave it. So we're going to do page 111. Let's do 9 part 1. Let's do 10 because I presume you didn't do it, and then let's do a load of hard questions. Let's do 13 to 18. And before you start, I'm going to talk about number 10 there for a minute. So 9 part 1, number 10, and then 13 to 18. The worksheet is for Friday, please. Worksheet is for Friday. Okay? So it's about 40 minutes. So that means if you do 10 minutes a night on the worksheet, you should be done by Friday. You Monday, Tuesday, Wednesday, Thursday, I'll do it. Is that okay? Right. Okay. And can I talk about number 10 before I leave you off? Right, okay, start the work. If you look at number 10 here, right, okay, number 10, here we are. Show that the curve y equals cos x has a point of inflection at x equals pi over 2. I just want to explain what pi over 2 means. In trigonometry, we will learn that there's actually two ways to measure angles. We can measure them in degrees or we can measure them in radians. Okay, when we're measuring in radians, and I will explain more when we get to trigonometry, pi is pi, as in it's 3.14 or whatever, right? But if you're talking about degrees, and for every math question that you do between the now and when we do trigonometry, pi stands for 180 degrees. So 180 over 2, so that's pi over 2 is actually a 90-degree angle, right? Pi over 4, what would pi over 4 be? It would be 180 divided by 4, which would be 45. So as far as you're concerned, girls, in any angle question, when you see pi, it's 180 degrees, right? Have you got that? And I'll explain more when we get to trigonometry, but for the moment, that'll be next year. For the moment, pi, if you see pi in relation to angles, obviously pi is 3.14 everywhere else, but if you're talking about angles, pi is 180 degrees. So if you just look at that question 10, it says, read that as show that the curve that has a point of inflection at x equals 90, right? Is that okay? Are we okay with that? Are we all fine? Right, okay, off you go, start your homework. So, picture up onto Teams, no bother. Right, okay.